Hello everyone, welcome to Coding Entity. So today we're going to talk about a lead code problem which is called number of matching sequence. So this question has been asked in Lead Code Daily Challenge July of 20th. So let's just talk about the problem statement now that we have been given a string s and array of strings word. Return the number of words I, that is a subsequence of s. So let's first talk about subsequences if you're not familiar with what is a subsequence. So let's say we have been given a string A, B, C, D, E. So a subsequence of A, B, C, D, E could be possibly A, C, E. Okay, so there are multiple subsequences possible, like one subsequence could be A, E as well. So this is about subsequences. Now what we have asked is, let's say we have given this string. Now we have to find that how many of these strings are one of the subsequence of the string s. We have to find that. So let's look at this example now that we have been given A. So we have a subsequence A present in our string. So in subsequence order of order matters, but the string could not be continuous. Okay, so A is a subsequence, BB is not a subsequence because we have one B present but there is no other B. ACD is also a subsequence. This is A, this is C, and this is D. So ACD is also a subsequence. ACE is also a subsequence. A, we have C, and we have E as well. So there are a total of 3 subsequences present in this string. Now our job is to find a total number of subsequences. So if we find out all of the subsequences, like that would take a lot of time. So that's one way of doing this question. Another way of doing it could be thinking that let's iterate over all of these characters, all of these strings. So let's say we have been given an array as A, BB, and ACD, and ACE. ACE. So these are the strings that we have been given, and we have to find a total number of subsequences in A, B, C, D, E. A, B, C, D, E. Okay, one way of doing it is that iterate over this array. Iterate over this array, and maximum length of this array could be 5 into 10 to the power 3. So length of this array could be 5 into 10 to the power 3. And each string could be of length 50. So each string could be of length 50. So that means that this string is called, we have been given name as words. Okay, so words of I dot length could be equals to 50. Another thing we have been given is the original string that we have been given, in which we have to find a total number of subsequences. That string length is 5 into 10 to the power 4. 5 into 10 to the power 4. So we are talking about the worst case possible. Okay, so in the worst case, what we can do is we have this string s, right? We can iterate over the array words, and for each index words I, we can look that whether that is a subsequence of s or not. So to do that, we would require a total of we will iterate in the words I, right? So what we are doing is we are iterating 10 to the power 4. So in loop, each time we are doing this amount of work, and we will run this loop a total number of length time, which is 5 into 10 to the power 3. If you multiply this, this will go beyond 10 to the power 8, and we want our answer to be inside 10 to the power 8. Right, so this would become, the time complexity will become 10 to the power 8. Time complexity will become 10 to the power 8. We want something less. So to do that, what can we do? Okay, so let's just think about that. So that means that we cannot solve it in a brute force fashion. We have to think of some other way of solving this question. Currently what we are doing is we are iterating over this string every time we are going inside this loop. We are changing the index we are every time iterating inside this loop. So that is one way of doing it. So let me give you an example what I'm trying to say. So let's say we have A, B, C, D, E, and we are at the index which is index 3. Okay, we are at the index 3. So here we have a string ACE. Now we want to find out that this at this index the string is a substring of this string or not. So what we can do is we can use a 2-pointer approach. So let's say this is I, this is I. So both of them are equal. This will go to C and this will go to B. They are not equal, so we'll go ahead in this string. This will go to C. This is again C. So we'll move forward both of these pointers. So they are IJ. Currently I've written I only, so they are IJ. So this is D and this is E. So we want to completely find this string in this string. That's why we are doing this. So we have found D, and so D is not equals to E. So we will just move past D. We'll come here. So both of them are equal. We'll move both of these pointers J and I. Once this I pointer is out of the bounds, we are going to return true that yeah, this is the substring of this string. Right? In the case of BB, we have another case BB. Wait one second, BB, and this was ACE. In the case of BB, we can find this B, but after iterating, we can see there is no other B present, and this J will go beyond the limits of this string. So that means that we cannot find the other character or the rest of the characters in our main string. That means that this string is not a substring of the main string. That's why we will not use the BB. Okay, so this was the brute force way, and you can see that in the worst case we have to iterate all over this main string, which is of 10 to the power 4, 5 into 10 to the power 4, and we have to do this a total number of 5 into 10 to the power 3 times, so that will go past 10 to the power 8 limit. So another way of doing this is let's store the indices of every character which is present in this string. So let's say A, B, C, D, E. So A index is 0, B index is 1, C index is 2, 3 and 4. We have stored the indices. Okay. So now what I am doing is let's only iterate over the small string. Okay. And the length of small string is so this string, right? And length of this string is is only 50. Yeah. So this string length is only 50. So what I'm doing is words of I am only iterating over this, and its size is equals to 50 only, right? Its size is equals to 50 only. So we are going to iterate over this, and using a single pointer we are going to iterate over this. Let's say that pointer is I. Okay, let's say this pointer is I, and yeah, we'll be doing that. And let's just take an example. So let's say we have this string ACE here. So we have ACE. Currently we are finding the 0th index, right? We are finding the 0th index, and we have the whole we have the whole string with us. So let's try to find the first index of A. So we can find that in this we have already stored this either using a map or using a 2D array as well. We can store this indexes. So we can see that first index of array is 0, right? First index of array is 0. That means that we can place our J at 0, right? And then when we have find A, we'll move our this I pointer to C, and this index is 1, right? To find this element, we can directly see here, this is at index 2. The first occurrence of C, it is at index 2. So we'll move our J pointer to index C, index basically this, where C is present, and we have skipped B, right? So that means that let's say there were several B's present, and we have C here. So we would have skipped all of these B's and directly jumped to C. Okay, we would have skipped directly all of these B's, and we would have jumped to C. So we have done this. After this, we're going to find E as well. So we'll go to E, and we'll skip this D as well. So why we were able to skip this B and D? Because we have already stored indexes of the element, and we can using these indexes we can find that whatever element we desire, what is the first occurrence of that, right? So this is one case. Another case to make this difficult, to make this intuition difficult, could be that let's say we have a string like A, B, C, D and A, right? So we have a string like this. So this is our string, and let's say that, and let's just try to make like the indexing of this as well. So this string, they have indexes 0, 1, 2, 3 and 4. So A would have at 0 index, at 4 index, B is at 1 index, C is at 2 index and D is at 3 index, right? And let's say we are trying to find a string which is called AA and BC, right? AABC. Okay, we are just trying to find this string, and we are just trying to find that is this a substring of this string, right? If this a substring of this string or not. So let's say this is some W of I element, right? This sub W of I element, or our words array have this element with us. So we are trying to find it. So what we did initially was we were just trying to find the 0th index, right? So the first occurrence of 0 index, and that is 0, right? So we have found our jth index. We have found our jth index. Now we will try to find the second occurrence of this, right? Of another array. We'll move this pointer to the next index, which is 1. Again we will find 0 index only, right? But we have to move this to find 4, right? We have to move this to find 4. So this is one way of doing this, and let me show you what I meant to say by that. If I only take the 0th index, that means that we are repeating element. To avoid repeating element, we can move forward, right? But now that we have moved forward, that means that J is pointing here. J is pointing here, right? Now we'll move this index to B, to the second index, right? We have moved this index to B, and now what we are trying to do is we are trying to find that whether B is present here or not, and B should be also present in order. So after A, B should be there. So using this, we are trying to find the index, and this index is 1, right? And there is no other index present with B. That means that 1 is less than 4. So current index was 4 and 1 is less than 4. That means that we have to return false. That means that there is no B present after 1, after this A. Okay, but if we look carefully, we have to iterate over this array every time, this index array every time, to find that like the current index is, so this jth index should always be lesser than this index. That's why we have to iterate all over this array. And in the worst case, again, this could again be 5 into 10 to the power 4, 5 into 10 to the power 4 times 5 into 10 to the power 3. Again, this could be that in the worst case. Another way of doing it is, let's say we have a lot of elements here. We have a lot of indices here. And we are currently at any jth index. Let's take the jth index as 5. We can use binary search in this array because this is already sorted. We have stored all of these indices in sorted manner. We can use binary search and we can find the index or the number which is just greater than 5, Either we will be able to find that index if, let's say, we are able to find 6 or 7 or 8, so any one of these. So if we are able to find 6, we are going to say that J will move at the pointer 6. If we are able to find 7, no, but not 6, we are going to say that J will now point at the index 7. If we are not able to find anything, if let's say the last element is 5 itself, that means that we are not able to find an element which is greater than 5. Then what we are going to do is we are just going to return that we could not find the element. That's why return false, right? So we can do this, and we can use a like kind of a binary search to find the index that we are looking for. So let me explain it to you through code. So this is our function, number matching subsequence, right? We have a string here and we have an array of words here. So what I did was I made a DP, and inside this I'm storing the indices for all of the 26 characters which could be present in the string. We have also been given that words I consist of only lowercase English letters. We have been also given this. Okay, so yeah, so we have DP like this, and we'll iterate over this string. Initially we'll iterate over this string using this for loop. I'm just iterating over this string, and using x I am able to find that at which index should I push the basically the should I push the index, right? So for a will be pushing at 0, for a will be pushing at 0th index, for b will be pushing at first index, for c will be pushing at second index, for z will be pushing at 25th index. So like this. So using this x variable I am able to find that index at which I have to put the index of string, right? Or at which part I have to put. Okay, so I'm just pushing back the index I, and this is it. And after this I'm maintaining a count variable, and I am iterating all over the words, right? All over words. So what I'm doing is every time we want to find an index which is just greater than j, right? So what we did was we currently made j point at -1th index, because element index which is just greater than -1 is 0. So we want to start from 0 only. That's why I have written this -1. And I index, it's pointing towards the basically the word, right? The word which we want to find that is the subsequence of our main string or not. Okay, so I'm using a function for this, and this function is going to return true or false. So inside this function we are here, and if I is equals to n, that means that we have iterated all over the word, right? Let me change this s to word as well, so that it would be not hard to identify word size. Okay, yeah, so we are iterating all over the word, and this n is the word or size. And if I is equals to n, that means that we have iterated all over the word. That means in that case I'll be returning true. Okay, this is true. And again I'm finding the index using this word I minus character a. Using this we can find like in our DP at what index we should look at. Okay, and I'm using an upper bound to find the next j just greater than the present j. Okay, so using upper bound I'm finding it in the like desired index array. In that desired index array I'm using this is just like a binary search, but this is an inbuilt function. So I'm using this, and I am finding the upper bound, and this is an iterator. So I'm finding that if this iterator is pointing at the end of our array, that means that there is no such index present in the array which is just greater than the index. Okay, so in that case we'll be returning false, else we'll be calling this function again with word, and we'll be increasing our ith pointer and the like current pointer which j is present. So let's say in this case second time we would have found the index 4, right? So the iterator is going to point here. So this is saying that value present at where the iterator is pointing. So value present is 4. So 4 is kind of like index. Okay. So we are doing this, and we are just calling this function again and again. So this is a recursive function call. And using this we are able to solve this. I hope you have understood it, and if you have any doubt, please feel free to ask it in the comments. Let me submit it as well, just to show you that it is working. Yeah, so this is working fine. So yeah, this is it. I hope you have understood it, and if you have any doubts regarding this, please feel free to ask it in the comments.